All right. Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. You can just use the questions tab there on your interface and submit your questions, and we will try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is 50 million data transactions a day with Cassandra. Our speaker today is Ryno Goosen, who is CTO and Managing Director of a company called Locstat. Ryno, thank you so much for joining me today. Really appreciate it.
Thank you, Charlene. Thank you for that introduction. And I'm really honored to act on this webinar today.
Excellent. Excellent. Well, I'm going to take myself off camera, put myself on mute, and let you get right into your presentation.
Okay, thanks. Okay, so I guess just as a start off of the webinar, just a quick agenda. So I'll start off by just giving you an overview of what Lockstat is and what it represents. Then I will look at how we decided what open source technologies to use in Lockstat. And then after that, I will follow up with looking at why we decided to use DataStax Enterprise in our solution space. And then, importantly, I would like to show you how we scale Lockstat with zero downtime. Just about Lockstat, we are Cape Town based in South Africa, and we see ourselves as leaders in graph-powered AI and event processing. And Lockstat is essentially a unified data analytics platform that enables organizations to rapidly create next-generation data intelligence applications in complex environments. What is quite unique about our software is a very strong combination of graph analytics combined with a very strong rules engine with event processing, and then, of course, machine learning tied into that. We help organizations to apply AI to monitor high-volume transactions in real time, giving them a 360 degree of their business, but trying to present them with threats and opportunities in their businesses by looking at solutions that increase customer loyalty, reduce churn, detect fraud, and obviously detect or reduce risk in the environment. We are focused on financial services, insurance industry, retail, manufacturing, supply chain management, and we've had quite a strong focus in safety and security in the past, and we've been quite effective in providing solutions in that space. Just to give you better context in terms of where Lockstat is placed as a solution, I'd like you to look at the bottom of the slide and view it from a perspective that the Industrial Revolution, especially the fourth Industrial Revolution with cyber physical systems, has created increased pressure on analytical systems to provide insights to organizations, simply because there's been a shift in the type of analytics that are required. And this shift is exacerbated by the advent of big data, and of course, what we're seeing a lot more these days is fast data, where you need to try and create solutions that give insights in seconds rather than in days or so. because what's very important in this space, especially where you're looking at time-critical decision-making, is to ensure that you have solutions that provide you with the capability to make earlier decisions on your data. Because invariably, if you are able to make earlier decisions, it has a sort of bottom line on your profit and margins of your organization. And typically, if we look at time-critical decision solutions, we're looking at high-volume event processing, fraud prevention solutions, supply chain intelligence, customer 360, risk monitoring, and then also manufacturing information systems. If you look at BI in this environment, I think what is quite an issue in the space where unified data analytic platforms are playing is the fact that your current BI systems tend to be developed from a SQL-based focus, and then add-ons are developed around that SQL core from a BI perspective to actually start augmenting those solutions to play in this space where real-time and augmented analytics are required. Now, typically in this space, there's a lot of technology uncertainty as to what components are required to provide solutions in this space. There's also quite a skill shortage around this in developing these type of applications, because you are looking at really high-end resources to develop these, and there are high costs associated with these type of applications. So, one of our big unique value propositions is that we reduce the time to implement solutions in this space. And of course, take away that technology uncertainty and to give certainty to customers in this space relating to the right technology sets in this new BI3 sort of environment. What's quite important for us in this space as well is especially from a real-time analytics perspective, is that you're also dealing with highly connected data in this environment. So you need very particular component sets to actually solve problems in this space to achieve time-critical decision-making and solutions that support that. So to solve this, we've developed Locstat. It's a SaaS application, and I think the key to Locstat is that it's a unified data analytics platform, but it's got a very specific focus on graph-powered AI and an event processing component that feeds into solutions that require real-time analytics and insights. What's been quite important for us in the space as well is to actually create templates in some of these environments to facilitate rapid deployments. And from this perspective, we've created templates specifically in environments like fraud prevention, customer 360, and supply chains, where we facilitate this rapid implementation in this space, obviously with graph playing quite a big role in this space. To move through the architecture of Lockstat, importantly is if you look at modern environments, you've got a lot of enterprise systems with a lot of disparate systems and data silos in organizations. And if you add to that sensors and IoT related applications in this space, there's quite a lot of data elements that need to be aggregated into a system such as Lockstat to give you that full-on 360 view of your environment. So, from an architecture point of view, it was quite important for us to cater for all eventualities in terms of linking to different data sets and sources and systems and environments in a company's operational sphere. So Importantly, we had to ensure that Locstat as a system is cloud agnostic and can be deployed in all of your major cloud providers, but also in private cloud environments that are not necessarily related to the three large cloud providers. So from Lockstat's architectural perspective, we have quite obviously a strong data lake component that information is streamed into through various middleware applications. We use Kafka quite extensively, which then streams data into a real-time analytics component, and also at the same time to this data lake environment, where we then feed data into a graph database environment. We've got a machine learning component in that and a very strong real-time computation engine. Because a lot of data in this space is geo-enabled, we've also got a geospatial computation engine in to render spatial data in real time and to provide spatial patterns and visualizations in the Lockstat geospatial environment. We've recently added a natural language processing component into it, and that's more related to entity extraction and resolution for linking text and voice documentation later on into our graph environment. But that's still in development. We have to have that released in probably the next 4 to 6 months. And then on top of this sits Lockstat, and part of this is a next generation complex event processing engine that feeds into the graph database, the machine learning component, and also the geospatial engine. And this is then linked to providing our customers, especially subject matter experts in an organization, with the ability to set very complex rules and condition monitoring components in the rules engine to monitor for any patterns and trends or anomalies in the environment. We have spent quite a number of time in setting up the rules engine in such a manner that it shields your subject matter experts from actually having to use coders to set rules or hard-code it in the environment. It's quite flexible, can be changed quite easily. And we've been quite successful in actually pushing that through in the organizations we've implemented Lockstat, and I'll show you something an example just after this. Then, of course, we've got a real-time view that gives you a full-on real-time view and a dashboard of information streaming in your environment. We've got a graph explorer to analyze graph patterns and explore your graph connections in your data. We've got a very strong geo view, and then, of course, the graph ML component and a very strong recommendation component, because in some instances, if you are doing event monitoring, you also want to have responses to that, and in some instances you want to recommend responses to events that have been triggered in the system. So like I said earlier, our sort of core uniqueness from a Lockstat perspective is the fact that there's a very strong association and integration between the rules engine and the streaming analytics component, and of course the graph database technology and the machine learning component, which all feed into the rules engine. This allows users to set quite complex rules to actually monitor for shifts in the graph database, looking at patterns and trends, and also for conditions if they change to be picked up by the rules engine. So from a vertical solutions perspective, we are focused a lot on financial services, like I said, where we look at high volume transaction monitoring, streaming analytics, fraud prevention, we're very strong on. Business 360, real-time analytics. In retail, we've also started to move in with Customer 360 and strong recommendation systems, and of course, churn prediction. And we've just started to move into supply chain logistics and manufacturing as well, with predictive maintenance solutions and manufacturing intelligence solutions in that space. What I don't have on here is obviously the safety and security space. We've been very successful in solutions in that space, which is obviously sensor and data rich and has a very strong geospatial analytics component in that space as well. So just to show you a case study, one of our largest clients is a company called Flash based in Cape Town, and they operate in the electronic voucher vending space, where they provide vending solutions for traders, where they on-sell cell phone data, airtime. They can make payments to certain vendors. And it provides their vendors with very specific vending solutions to on-sell products into that space and to make payments, buy electricity and such. They've got in the region of about 200,000 vending devices in the environment, through which they allow their traders to vend to customers in the space. So we provide them with a risk management solution to monitor their transaction space. Now it's quite a complex transaction space because of the different products that they on-sell and related components that go with this in vending in this type of environment. So the complexity in the space is quite higher than it would be, for instance, for a pure credit card solution where you are looking at payments just from a credit card perspective. So if you look at the Flash solution, Locstat processes approximately 50 million transactions per day, and we monitor that for them for various risks and opportunities. It's not only their transaction environment, but also their production systems that we monitor in terms of performance or any problems on their production systems. During peak hours, we process about 5 million transactional messages per hour, and that's about 1,386 messages per second. We stream about 20 different data streams into the environment. There's an uptime of about 99.8%. The whole solution runs on 13 nodes in a cluster to ensure high availability. And then Flash have a specific team that monitors exceptions in real time, and they can follow up on it and close the loop on those exceptions. It's across 5 divisions of the organization, and then they on a daily basis, they have about 360 rule breaks. We also close accounts in real time if critical rules are broken, and in the region of about 20 accounts are broken on average per month, which gives you a very good indication of how we manage to control false positives and false negatives. And then, of course, once a critical rule is broken, it takes about 2 seconds for the system to put a message back in the environment to automatically close an account. Now, I think one of the real changes or benefits we brought to Flash is the fact that we extensively use graph and the graph component of Lockstat to actually model the full transaction space. And we use graph extensively to look for patterns and trends from a risk perspective, because it's, we look at growth in networks of their traders and how quickly they grow, and we link that with other contextual information, which is very specific to Flash to manage risk in that environment. To give you an example of some of the interfaces, it's on the left-hand side, we have a sort of a real-time dashboard which gives Flash a sort of real-time view on their transaction space. They can see all the different products and how how their customers are transacting based on windows that we set. In the middle, you have the sort of rules engine environment, and that's the space where Flash's subject matter experts can actually go in and set very complex rules to monitor the underlying environment. Then we have a graph visualization and exploration component, and what we've done there is to actually shield Flash's users from actually having to know the complex components of graph queries. There are some experts in Flash that are able to do that, but in general, we've shielded most of the users from actually having to use or know those extensive and complex graph components to visualize graph patterns in the system. And then, of course, Flash has quite a strong data science component and group in the environment, and we provide them with a notebook environment to provide them with access to highly curated data in the environment, and they access that through Jupyter notebooks, where they then can model their environments, their machine learning, and other analytical models that they want to evaluate, and then we can actually operationalize them in the system for them using this method. So, how did we decide what open source technologies to use? If you look at the origins of Locstat, we've been using graph technology for probably the last 10 years already. And we got in very early in that space because of a sister company that was linked to Locstat. We developed very specific solutions in the domain awareness space where you would use a host of sensors like air surveillance radars, ground surveillance radars, and link that to other data sets, incident databases, social media data, and then create a pattern of life in an area to look for shifts in patterns in an area due to crime behavior or such. So we had very high analytical overheads in generating these type of environments. And if you look at the technology requirements of that environment, you have to follow a layered approach where we had our sensor and data sources, and then obviously you need a sensor data distribution component to pull or push that sensor-based data into your visualization environment, and of course then create a ability to actually analyze historical-based data and then revisualize that in a geospatial environment to layer behind your real-time patterns and trends. Now, for that we used AGI. They have a engine that allows you to create really complex spatial visualization environments, but it's run, in those days it was run on an actual desktop environment. And we used Future Point Systems, which was probably one of the best visual analytics systems that I've dealt with before. They're not around anymore, but we sort of cut our teeth on Future Point Systems as a visual analytics system, and that sort of introduced us to the power of graph. And it also enforced that realization in us that, if you want to use a graph capability successful, you need quite a strong data engineering capability prepare data before you actually use it in a graph to visualize, and then use graph algorithms to look at closeness between nodes and entities and individuals in these type of applications. Now, one of the big problems at that stage that we had was that we were having big problems streaming radar, AIS, and ADSB data into this environment, because SQL just couldn't handle the write speeds required to actually stream this high volume data into this environment. So we had to look for an alternative in those days to SQL. And at that stage, we also developed a sort of a middleware application to stream data in real time. And it was closer associated to your data distribution services like OpenSplice, which was used a lot, especially in naval vessels, to create a publish and subscribe real-time environment for sensors and effectors in that space. And then we also used software from Cambridge Pixel that allowed us to do a lot of sensor fusion and tracking analytics. You know, that sort of drove us to look for a different database to manage that. And the requirements at that stage, what we were looking for was a very strong real-time sensor data component where that database had high performance writes and reads capability. We were looking for elastic scalability, extreme resilience and fault tolerance, and then obviously flexibility in supporting our analytics. So the data structure that we were looking for would have had to be flexible enough to allow for very different data types and manipulation of that data so that we could analyze it later on. And then, of course, data compression was very important for us. And you know, we looked at a couple of databases, Redis for one, but we settled on Cassandra, and we've simply never looked back since we've selected Cassandra as the underlying data store component or database for Lockstat. So at that stage, we realized that, you know, once Cassandra is there, it's all good and well, but because we had a very strong geospatial component where we had to make geospatial queries, we also needed some index capability to find data in Cassandra. But obviously, you know, whatever indexing capability we chose, it would need to be compatible with how Cassandra scales in this environment. And we looked at Lucene first, but then settled on Solar. And at that stage, Solar and Cassandra represented our backend database and indexing capability through which we then would draw data out to Starlight future point systems to do data engineering and visualization in the visual analytics space. At the same time, all data would be streamed into the front-end environment, which at that stage was a thick client or a desktop-based application. We started developing a server-based application in CCM, which is an open source geospatial environment for time-critical data patterning, and that's specifically suited to high-volume transaction and visualization patterning system. But at that stage, we made a shift from more sort of military applications to the commercial sector. And in that pivot, we realized that we had to re-architect our environment and make it more cloud compatible. And I think importantly, how we did that was to follow a very structured, layered approach that would drive this strategy of ours to look for open source components that we could use in this space to build a Lockstat on top of. So obviously, we decided that we would look for products from the middleware message layer upwards, data storage layer, indexing and search layer, processing and analytics layer, and then of course visualizations, UI, and the management control layer. What was quite important for us is that we had very specific requirements. The one is that we had to find a spatial data processing engine that would enable us to not only crunch very large data sets, but visualize those data sets spatially with a processing capability that would do that in real time. We had a big need for a graph database. Whatever graphing component or solution we had looked for would need to conform to the products we had already selected in the underlying layers, such as Cassandra and Solar. Then, of course, what was critically important was a scalable computation engine, because we needed the necessary components to run really complex algorithms to look at recreating that sensor fusion components that we previously were struggling with on the desktop-based applications. So we looked for something with a strong streaming analytics component, machine learning libraries, and of course it had to support a distributed graph processing framework. So after a lot of research, we selected 3 products. At that stage, we selected Titan as a graph database. What's important in this is that selecting these products, there had to be a very strong commonality in underlying support, not only for Cassandra, but supporting interactions between these elements. We selected GeoTrellis, which provides multi-dimensional space filling curves that basically enables you to translate multi-dimensional indices into a single dimension. So for instance, you may have a lot of variables in data and you want to view the effect of shifts or changes in these variables in real time in a vector-based visualization from a geospatial point of view. And that's quite important in looking at image processing, yield predictions, and importantly, machine learning support for crime risk forecasting, where we were very successful in using GeoTrellis. And then, of course, we selected Spark because of Spark's close integration or commonality with GeoTrellis and Titan and underlying Cassandra database. So that's why I've highlighted it out specifically to show those commonalities. And of course, why we selected Spark was that Spark streaming capability, also the linear scalability, the ML libraries, but importantly also that GraphX component for graph computation. And of course, importantly, the ability to source a data schema where you can use source data schema inference and create tables on the fly. And that's a very powerful capability of Flash that, not Flash, Spark, that is a reason why we selected that. And then, of course, if you look at the metrics, obviously graph powering was quite important, but we used a sort of a scoring system to link the different products based on Apache Cassandra's capability. Then, of course, very important, elastic and linear scalability, Spark compatibility or dependencies, and then that score. The only real issue there that we found was probably with Kafka, and the Kafka doesn't, it's fine in a single region, but as soon as you go across data center from a replication point of view, one can run into problems. It's not insurmountable, but it can create problems. So the eventual products that we selected was obviously Kafka from a middleware component, writing into our data storage layer, where we're going to use Titan, obviously with Tinkerpop and Gremlin as a graph processing framework, with Solar indexing on top of that. and then Spark as a computation engine, feeding into GeoTrellis and Cesium, which are then sort of layered in a Varden background where we used D3 and charts.js as the charting or dashboarding components. So it's a very powerful link between geospatial and dashboard environments to give 2D and 3D visualizations in that space. So why did we decide to use DataStax? Well, it's actually quite simple, is that if you look at the underlying core elements of the Lockstat Foundation, it's Cassandra, Solar, Spark, and then obviously Titan, with Tinkerpop and Gremlin. And when we looked at DataStax were, I think, just at the point where they took over Titan as a graph database and then rewrote it as DataStax Enterprise Graph. So in a sense, it made our decision quite simple to look at DataStax because of how closely DataStax resembled that open source framework that we use as a base for the Lockstat product. What was also quite important for us was that we were looking to follow quite a strict data fabric approach where you stream the information into the environment, you do format conversion with the ability to fuse the data into the NoSQL storage environment, and then you have feature engineering and modeling on top of that with a graph database and other AI technology. But importantly, we were quite set on looking for something that would help us looking at data governance, policies, metadata and cataloging, and of course, data security was also quite a strong consideration in looking for something to support that underlying component of Lockstat. So that data fabric approach was quite strong in our decision making as well. So then if you look at DataStax Enterprise on the whole and all the features and functionality that they present, DataStax really provides us with a sort of a force multiplier in that underlying foundation that Lockstat rests on, because of the fact that it says Cassandra as a underlying model. And then, of course, DataStax has their own version of Spark through their operational analytics, enhanced search, which is essentially Solar deeply integrated into that environment. The graph engine, which has subsequently been updated, and there's a very tight, deeper integration with Cassandra, which gives a very strong performance enhancement when using graph and running graph queries and analytics. And then, of course, the integration components that goes with that, which makes implementing Lockstat a lot easier. And then also importantly, the thought leadership that goes into developing DSE helps us a lot, and it helps us focusing more on the important components in Lockstat rather than the underlying foundation components. So just to give you an idea of the performance enhancements that it provides us, if we had used only the open source components and had to integrate and manage all of those components ourselves. Obviously, DataStax provides us with that advanced performance enhancements in terms of the core architecture. The analytics engine is 3 times quicker than the open source components. The graph performance has increased tenfold since the deeper integration with Cassandra. And then obviously the enterprise-grade security, like I said, from a governance, security, and that fabric approach. The multi-model data component is critical in our environment because like I said, it's very difficult using a graph database component on its own if you don't have supporting technologies to actually do that data engineering that helps you with entity resolution when you eventually load your data in your graph database component. So it's critically to have those supporting elements under your graphing component. So as I said earlier, DataStax help us to focus on our important components. So we don't have to actually focus on those underlying components of the Locstat Foundation, open source components. Only real areas where we have to still manage things ourselves with the geospatial engine and now with the natural language processing component. But it does really make a difference in our development efforts because we are essentially a startup. And we 4 years old, but it really makes a big difference in a environment like this if those elements are catered for by a very strong solution underneath it. So how do we scale with zero downtime? I will show you this based on an example. So if you look at the Flash hosting environment specifically to support their solution. Now, we support most of our clients where we have a multi-tenancy component in our Locstat SaaS environment, but for Flash, we've separated that out. It's in the same hosting environment, but it's separate, separately hosted for them. We use 13 server nodes, which is a combination between Locstat and DataStax, the underlying DataStax components. We have one front end. We will be shifting that front end on top of or as part of the other applications on the nodes. And actually, running the risk solution, we have 8 Locstat nodes, and then we also have a ML machine learning cluster for Flash, which is provided by 4 nodes, where the data science team can work with the data and run their models and do their bit. And then, of course, we all run that in a Docker environment, and I think we started off initially with it was about 6 nodes, or 5 or 6 nodes, and that has progressively increased to what you see now. And it's simply a case of adding nodes when it is required. The nice thing about DataStax as well is that if you look at the hosting environment now, it's not a pure cloud hosting environment. It's still physical machines in this environment, but it gives us that flexibility to do so in a physical server environment with the ability to scale to the larger cloud providers later on. We initially ran Locstat in Google Cloud, but at that stage, Google Cloud didn't have data centers in South Africa, and we had a marked latency issue from a real-time perspective at that stage. So we will be shifting into those other cloud providers later. Obviously, shifting has cost implications, but using those cloud applications also has quite a big performance enhancement in using this type of software. And we also have a mobile application framework that for reporting data into this environment, and that we use Xamarin for, and then that links into Karaf, but links through our dark matter sensor bus into the rest of the environment. And that is basically the end of my presentation. Any questions?
Oh, can you see me?
I can.
Okay, great. Yes, if you have a question for Ryno, go ahead and use your question and answer tab, and we will try and get through as many as we can. Let's see what we have here for you so far. We have, okay, here's one. Are there any plans to integrate other graph databases into the Locstat environment?
Charlene, we use, because we use Tinkerpop and Gremlin as a graph, as a framework, we are quite open to integrating other graph databases, and we have some on our development roadmap, but that's for later down the line. There are a couple we have in mind, but it's not a high priority at this stage.
Okay, all right, great. Let's see, we have one more. So if you guys have a question for Ryno for the question and answer period, please go ahead and just use that Q&A tab. Let's see, are there any considerations regarding other middleware applications or software?
Charlene, because of the issues that I mentioned of Kafka, when you want to go cross-region, we are looking at Pulsar, and if you look at the way DataStax is going now with Pulsar, we will probably at some stage look at shifting to Pulsar in the future.
Excellent. Okay. Got another question here for you. How much latency are you able to reduce away from GCP?
I think, latency, if I look at latency in especially the transaction space, it's about 200 milliseconds, I would say.
Okay. All right, great. Well, that is all the questions that we have so far, but I'll leave the question and answer period open for a little bit, see if we get any more questions in from the audience. While we're waiting, just a quick reminder that today's event is being recorded. So if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Excuse me. Yeah, we've not gotten any more questions in for you, but as I said, I'm going to go ahead and leave it on while I go through the rest of my little housekeeping announcements here. And if we get any more in, then we'll just go ahead and address them before we close things down. One of the things I did want to mention at the top of the hour, we did say that we would be doing a drawing for $25 Amazon gift cards. And let's see, it looks like we have our 4 winners all selected here. Our first winner today is Nick R. Congratulations, Nick. Our second winner today is Robert S. Congratulations, Robert. Our third winner today is John R. Congratulations, John. And our fourth and final winner today is Diego G. Congratulations, Diego. We'll be following up with all 4 of you to get your gift card over to you via email. So check your inbox if it's not there. Check your spam folder, because you know how that goes. Okay, great. So Ryno, I guess you just went through everything so well. Folks don't have questions. But I do want to thank the folks who did submit questions. If you do have a last minute question, you can go ahead and use your your question and answer tab and put your question in, and absolutely the folks with will be more than happy to follow up with you offline. It looks like we may have just gotten one. Okay, so we did get one actually comment. We are bound by company standards. Databases are restricted to the big boys, SQL Server, Oracle, etc. Are these databases catching up, or do you still recommend Cassandra?
I would still recommend Cassandra, but at the same time, you're not going to throw out your SQL-based databases, because I see that just as a filtering component. You're not going to get rid of SQL. SQL still has a long way to go. It's more taking hybrid approaches. SQL always will have its space in your environment, but I think it's important to realize that if you're going real time, you have to shift to these type of bases to cater for that type of computational power that you need to create these type of applications. SQL simply just cannot manage that volumes in terms of writing to SQL databases.
All right, great. Yeah. Okay. I'm just checking here to see if we got any more, and it doesn't look like we did. So, like I said before, if you do have a last-minute question, you can go ahead and use the question and answer tab. We'll collect all of the questions that came in, and somebody from the organization will follow up with you offline. But for now, I do want to thank Ryno Goosen for a great presentation. Lots of really interesting stuff. So thank you for kind of parsing out the technology and how you guys are using it. There's such great information in that email, or in that presentation. So thank you very much for going through that. We really appreciate it.
Oh, thank you. It's a pleasure. I really enjoyed this webinar.
Excellent, excellent, excellent. And excuse me. I also want to thank the audience for joining me today. And I hope everybody has a great day, and I hope above everything you all stay safe. So enjoy your day. We'll talk to you later. This is Charlene O'Hanlon signing off.
Everybody, goodbye.